So this is our team. And then I was just talking about, here's the traditional method in which things work. There's an owner, they hire the architect, construction firm, the engineer. Sometimes the engineer is hired separately. Sometimes they're underneath the umbrella of the architect or the construction firm. Ultimately, this diagram ends up with all the guns pointing at each other. Everybody's suing each other. They're all upset with each other. And no one's on the same page. Typically what happens, the architect gets the contract, the client's going, go, 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 get that permit. So what does the architect do? It says to the structural engineer, give me my drawings, right? So you get all your drawings. Do the same thing with all the other engineers. They bring it all together. At that point, the architect is supposed to take all the engineering drawings, make sure they're all synchronized. And what do? They staple them all together and say, get back to plan check, quick. They never do that work. So you guys and gals get a call later on that says, your stuff's not in the right place. Why didn't you let us know? Didn't anyone take a look at this? And usually they find this out when everything's under construction. Then it really gets maddening, right? So this process of design build, which you'll see, I think some of the bridge builders and everybody else, they know we don't have the ability, we don't want to start fighting with each other. We want to go smoother. So this takes some of that out of there. Go to the next slide. All right, so now this gets really complicated, right? You have the client who hires the builder. The builder says, oh, we've already designed a project with an architect. Can we make it modular now? And they go, oh boy. That's when they bring it to us and say, and the building looks like the Disney concert hall, right? It's got all these things going on and say, can you put this in a modular space? I'm like, I can't do that. But then we try. But by the time it's all said and done, they're like, I have to redo all the architecture. I have to redo all the structural. Slowly but surely, these folks are learning that if you simply get together with a company like ours or someone who's modular friendly in the architectural world, they get together with the structural engineers. Structural engineers always understand it. It's the architects who come in and say, can I do this and can I do that? And they think it stifles their creativity. Once they really understand it, it actually enhances it quite a bit. You can't do the Disney concert hall, but they can do things far more efficiently than we're doing it currently. All right, let's go to the next one. All right, so at this point, this is our studio, okay? This is the beast, the belly of the beast, all right?
The interesting thing with Peter talks, so you go through the architecture, you go through the designs, now make it work, This is the print shop, this is the printer, this is the 3D printer, whatever you want to call it. So right now, this one sits in Southgate, it's about 100,000 square feet under the roof. Everything you see right there, we go from the coils to the screws. Everything there, we roll form. You go to the shop any day, it looks that way. We believe in order, precision. So incorporating some of the manufacture process that some of the industries have into construction makes a big deal. Making a modular company doesn't mean that you go out in the field, you hire all the trades, you rent the place, you bring everybody under the roof, and things are going to change. The only thing that happens is they get lazier because now they walk less. You have less control of the people. So you have to design systems and procedures. And systems and procedures end up replacing people. And when I mean replacing people, it allows a worker that doesn't show up on Monday because his kid is sick will not stop the manufacture process because there's a procedure to follow. So it actually gives the versatility to the employees and the employer to be at any place, any location. So by elaborating this 2D, 3D drawings and then making that 3D drawing into a reality through CNC files, to cutting material to the size, to creating procedures, is what we do here.
So this is basically who we are. This is our company. And we do not just separate ourselves as fabricators or as architects. We have the in-house engineering. We have the architecture. Basically, we're creating that design build model even tighter than what it was before. And that gives you an immense amount of control over the project.
So some of the projects that we've done, we did this with DPR. I don't know if you guys know who DPR is. DPR is, Clark's Construction competition. I think they're both almost head-to-head, correct? They're probably one of the largest technological GCs you can work for or do business with, So we performed to those guys. So we did Otis College with DPR, a lot of coordination. By being a metal building, we try to stay away from wood, and we're in the type 1 construction. So we're always in 2-hour fire ratings. So our niche markets are assisted living, student housing, some hotels, it depends on the zoning. And now we're going into this modular just because the ability of what's going on in LA, that right now everybody's going With a type 3, they're going 80 stories, 5 stories in wood, 3 over podium. But the building code is about to change. You know, the code is going to change in LA at least. And it's going to go, I think it's going to be pushed more by the fire marshal than the city inspector. So the stuff that we've been talking, I mean, you've been in those meetings, it looks like probably LA, I don't know if San Diego, by the next 5 years, it will go non-combustible. Just because of the density of these buildings, wood is going to be out. So the only alternative is going to be concrete or steel or any non-combustible. And if you want to be competitive with wood, the closest you can get is light gauge. And if you look at prices today, we're probably 30% more expensive than wood on a stud-by-stud element, but we're 5% over in the overall price. Insurance rates are not starting to insure wood buildings. So now we're getting all this premium from the insurance companies that somebody who builds anything in steel against wood, within 5 to 6 years will get his money back on the insurance premium. So there's 2 types of customers that we deal with. The guys, I call them the flippers. The guys who buy a building, they build it, they flip it, and they walk away. That's wood for them, you know. But if you're the owner who keeps the building, rents the building, you're better off with steel. You know, and some of these assisted livings, there's no trade. You know, assisted living, anything above 3 floors, type 1. Anything below that. So this is kind of the buildings that we do. We have developed our own softwares. We use compression tables in order to get the accuracy of the screw. I mean, a lot of these new systems, the frame cats and the other machines, rely on the shear of the screw when the studs sit, and you know that's not going to work. I mean, especially like the stuff we're doing right now, 10 stories. Imagine relying on the shear of a screw. The shear of a screw on what, 16 gauge is probably like 400 pounds, 300 pounds, and you're holding a whole building. So we use compression tables in order to accomplish that. This is our framing line. We run 3 framing lines with compression tables. Right there, we can probably do about 1,000 linear feet of walls a day. So 3 guys per line, 9 guys, 1,000 linear feet a day. Low bearing. That's the shop outside. We have, through time and through experience, we have created what I call a perfect product for an imperfect world, which is construction, correct? So you always deal with tolerance. So if you see right here, each of these units is a floor plan. A floor joist plan probably spans anywhere between 13 to 14 feet. But every of these panels are ledger hung in between this wall. So the panel flies in between. This is a 9-story building. And as you go up, if your walls are not plumb, I mean, you saw what you saw in the concrete building, how do you control this tolerance? So what we design is spaces. This is, so a unit, you can see a unit is right here. So these panels will stack against each other and we'll give a 24-inch tolerance by misaligning the joists against the studs. And something that we do is we increase the gauge of the track to create a header so you don't have your typical inline framing that you have in wood. So a lot of these things allow you to create certain tolerance. Our panels are 3/4 of an inch shorter this way. So when the panel drops, it's 3/4 of an inch, it drops and expands. So it allows enough tolerance to be imperfect in a world where every wall needs to be plumb. And you know that's not true in construction. Something too that we learn is that by us taking the leadership on the drawings, and I think I encourage you guys, learn how to draw. Learn AutoCAD, learn Revit, learn class detection, learn Navisworks. It's there. I mean, if you think a calculation on an Excel sheet and something else is gonna solve your problem, if you don't know how to draw, you won't be able to get to this level. You know, and take the advantage that you probably get free licenses while you're in school. And there's 2 things I don't fight anymore. I used to fight every software in the industry. Now I make my peace with Microsoft and Autodesk. After COVID, they took over. There's nothing you can do. I mean, how do you fight against Teams and Microsoft when you have to coordinate things? You know, Google doesn't do it. Teams does a complete stream. You can bring all these softwares. You know, you go from Excel to Access to Power BI, and then you get all your databases. You can defeat that, correct? Then you go to AutoCAD. Before it was only AutoCAD. Then Revit came in place. Then BIM 360. And then all this online coordinations, you can't beat it. I mean, you can get now a $25 seat per person on BIM 360. You can upload a Revit model and do full coordination, full nodes without even having Revit or AutoCAD. So you're never going to beat them. So learn how to use those tools. It's kind of interesting because in construction, you know, you guys and architects that we get the education, we have to lead this group of people that come to us. So there's other tools, you know, especially in engineering, there's a lot of new tools coming in. Learn how to use it. What we do is usually the biggest software is in the MEPs. MEPs have probably the most technology, just because of the connection they have to do with the air conditioners and everything else. They have really developed softwares. In the architecture and engineering world, we don't have that many tools besides Revit and some other stuff. I mean, SolidWorks, if you want to go really strong into that. So what we do is we actually have told the MEPs, step to the side. We're just a stupid framer that's the primary structure. Let us do the drawings. So now we draw for everybody. And then we hand over our models, our structural models to the MEP. And that, you as an engineer, after you take the leadership, you should tell the architect, you know what, step to the side, let me take care of whatever's inside your walls. And that's what I shall tell Peter. I said, you dream, let me take care of what's inside the walls, and then you hand over that to the MEPs and you take control. So if you see here, we tell the plumber where he goes before the tension and all the precast comes in place. We tell where the hold down's done. So we do a layout before. And if you see this is a very unique wall. This is a shear wall with some rods right there. There's a toilet right there. There's some plumbing. There's some HSS going up to the roof because there's an eyebrow, architectural eyebrow. So that wall is very unique with plumbing, structural, shear, everything else. And then when our panels land, we're within 1/16 of an inch. Here we even take the advantage that this is actually in Carlsbad behind Legoland, where we tell the structure steel, which is like a prima donna in the construction industry. They think they come first, they put the structure, they weld it, and they walk away. We tell them, you know what, walk away. You'll come when your time comes. So we ask them, what's your tolerance? So he usually tells, hey, for our brace frames, we need 1/2 inch in between your joists because we're going to be a lateral support. We want no loads. We just want to connect lateral to your building. So we actually allow them to come in once we build, this is a 3-story building. See, we built the 3 stories, then brace frames come in. Because if we were to come in first, you would have cables, you have all these things, and when you fly in panels, those cables are in the way. And usually by the time he does the welding, he doesn't plumb. I mean, there's no way he can plumb 3 stories. By the time you go up, his brace frame is outside the walls.